Hello everyone, I'm Rajasri, Assistant Professor, Department of EEE, working at MLR Institute of Technology, Hyderabad. And in today's lecture, I'll be discussing effect of source inductance. So far, we have seen R load, RL load, RLE load. The inductance we have used only in load, whereas here, what will be the effect of inductance if at all, if we are making use of that particular inductance in source, that we're gonna analyze. And here initially, see, I have considered a full converter which consists of all the 4 thyristors, and here I am making use of RL load, that is resistance as well as inductance is present. And apart from that, here I am making use of a source inductor, that is indicated with LS. So initially, during the positive half cycle, what is the basic purpose of converter? It converts AC to DC. That means the supply voltage is AC, which is alternating in nature. That means it has got both positive half cycle as well as negative half cycle. And the moment when we provide the triggering pulse, see, at this instant called alpha, we usually provide the triggering pulse. Okay, but our thyristor will be triggered at this particular instant. This is alpha, and at this particular instant called alpha plus mu, our thyristor is getting triggered, and because of which at this instant from alpha plus mu, thyristor started conducting, and it is conducting till alpha pi plus alpha. And at this instant called pi plus alpha, when we provide the triggering pulse, again at this instant thyristor starts conducting. So this is how the output voltage waveform looks like with effect of source inductance. Why is it different from the waveforms which we have already seen? See, let me connect this to the back end, and this is how it looks like, and this is the output voltage waveform with source inductance. That is, at this instant called alpha plus mu, see, positive half cycle has been appeared, and because of which polarities will be positive, negative, and thyristor 1 and 2 is conducting current through the load in this direction. Yes, this is a well-known fact. In the positive half cycle, thyristor 1 and 2 will be conducting, and that is how here T1 and T2 is conducting the output voltage. That means whatever the source voltage which we are feeding is applied across the load during this positive half cycle. Because T1 and T2 are short circuited, whatever the voltage which we are supplying will be appeared across the load, and that is how during this period we get V0 is equal to Vs. So from this instant called alpha plus mu till pi plus alpha, T1 and T2 is conducting a current through the load. Okay, and at this instant called pi, what happens? Usually negative half cycle appears, and because of which T1 and T2 need to be turned off. But here inductor is present. During the positive half cycle, inductor is charging, and by the time positive half cycle is completely completed, there will be certain amount of energy stored in the inductor, and that is VL is equal to L into di naught by dt. And inductor changes its polarities so as to maintain T1 and T2 still in conduction state even during the negative half cycle. Why is it so? It is because inductor, it does not allow any sudden changes in the current. So that is the reason it tends to maintain the current flow in the same direction. So that is the reason it reverses the polarity according to Lenz's law. And that is how we are getting the output current right from pi to pi plus alpha. And the moment it reaches pi plus alpha, actually T1 and T2 need to get turned off. If you see here, actually here negative, whatever the energy stored in the inductor, it is completely dissipated, and T1, T2 actually it need to be turned off. But here what happens is, see, during this period, that is from pi plus alpha to this instant, that is pi plus alpha to pi plus mu, pi plus alpha to pi plus mu plus alpha, at this instant what is happening is both T1 and T2 is conducting, as well as T3 and T4 is conducting. It is because negative half cycle has been appeared, and because of the negative half cycle, what happens, T3 and T4 will be getting turned on, T3 and T4 will be getting turned on, and because of which it is conducting a current through the load. And at the same time, T1 and T2 is also, it is in the on position. During this period, I am talking about during this period, both T1 as well as T2 and T3 as well as T4 is also on. It is because whatever the source inductance, energy stored in the source inductance, will be maintaining T1 and T2 still in conduction state, whereas T3 and T4 are turned on due to the negative half cycle. So that is the reason T1, T2 as well as T3, T4, all the 4 thyristors will be turned on during this period of time. We call this period as overlap period. We call this period as overlapping period. That is from the instant pi plus alpha to pi plus alpha plus mu. Pi plus alpha plus mu. So here during this period, see, initially current will be building at a slow rate. This current is increasing, and this current is due to the current flowing through thyristor 1 and thyristor 2. Current is building and it is increasing, and it is remained constant. This is the current through T1 and T2. And again, due to positive half cycle, the cycle repeats. And if you see a current through thyristor 3 and 4, it will be building, it will be increasing at this instant, and again it stabilizes and it gets reduced. So at this instant called T1, T2, see here, current through T1 and T2 is getting reduced, and at the same instant current through T3 and T4 is actually increasing. And finally, T1, T2 is getting turned off once the energy stored in the source inductor is completely dissipated, and by that time, because of the negative half cycle, T3 and T4 are getting turned on. And if you see here, even here, see, there is the same output voltage from alpha plus mu to pi plus alpha. And here, if you see, during this period, thyristor 1 and 2 is conducting during the positive half cycle, and by the time it reaches pi, what is happening? Because of the load inductor, the current continuity is maintaining. And if you see at this instant called pi plus alpha to pi plus alpha plus mu, current through thyristor 1 and 2 is getting reduced, because what of the energy stored in the source inductor is getting dissipated through T1 and T2, and during the same period current through T3 and T4 is increasing. It is because of the negative half cycle, T3 and T4 are being turned on. So that is the reason current is increasing at a slow rate. And finally, this is the output voltage. So at this instant from pi plus alpha to pi plus alpha plus mu, both the thyristors, that is T1, T2 as well as T3, T4 are turned on, and we call this as overlapping period. And even here, if you see here, during this instant, that is during overlapping period, T1 and T2 is on, and at the same time T3 as well as T4 is also on. All the 4 thyristors are on, and we call this period as overlapping period. So that is the effect of source inductance. And in the next lecture, we will be seeing single phase dial converter. And before which, let me derive the expression for V0 average for this particular circuit, if at all, if source inductance is considered. In that case, we have V naught average is equal to the general formula we have is 1 by T 0 to T V naught of omega T d omega T, where here time period is every cycle, similar cycle is repeating for pi. So that is the reason here time period will be taken as pi, and it is actually conducting from alpha plus mu, because it is started conduction from alpha plus mu, and how far it is conducting? It is conducting till pi plus alpha, where V naught is equal to Vm of sine omega t d omega t, and here bringing it out, constant bringing it out, Vm by pi, and integration of sine is minus cos omega t, conducting from alpha plus mu to pi plus alpha, and if you substitute, we get Vm by pi cos alpha plus cos alpha plus mu. This is the V naught average expression. In the coming lecture, we'll be seeing single phase Dial converter. Thank you.